Chapter 3 review packet, page 3. So what we're going to work on is mapping one congruent figure onto the other. So there's going to require usually three steps. So the first step is we either perform a line reflection or not to match orientation between the first figure and the final figure. Okay. So sometimes we'll perform that line reflection to match orientation, sometimes we won't. The second move will be a translation to match one pair of corresponding points. And then if necessary to match a second pair of corresponding points, we will rotate. So first, we should have given you the 3 points, and we should have also told you that they were congruent. So we can assume those things. You know, it's chapter 3. Everything's rigid motions. So it's kind of assumed that they're going to be congruent. Okay. Now, what you're going to notice is orientation is counterclockwise for both triangle ABC and triangle DEF. So we're not going to need that line reflection. Orientation is already preserved. The second thing is we're going to translate to match one pair of corresponding points. So B to E. And what I noticed was when I connected B to E and then connected A to D, it looked like they were going to be parallel as well as the same length. So I think that it's safe to say that a translation is the only move we need, because that's going to, again, orientation is the same, and that's going to give us two pairs of corresponding vertices in the same location. So we'll assume that that's all that's needed. I'm just showing the work for orientation. Okay. You don't have to say vector or directed segment this year. We would have last year. You just can say this year, you can say that maps B to E, and that'll be enough. I marked really quickly there. It showed that I marked they were parallel and congruent. So I really don't need that rotation. That's kind of what that's saying. All right, number 9. Same thing. I'm going to make it MATH and then prime 8 prime T prime H. All right, orientation again is preserved. So they're both clockwise orientation. Now, since H is invariant, means it's not going to move, or it's already where we want it to be, we don't need that translation because we already have a pair of points that's matched. Our third move really, orientation was already preserved, so we didn't need a line reflection. That's step 1. Translation wasn't necessary because we already had a point that was in its location. So all we have to do is rotate centered at that point, H. And you don't normally have to tell me the exact degrees. Usually you could say M, H, M prime. But we know it's a rectangle, so we know it's 90 degrees. So we're going to say 90 degrees, and we do have to say the center so that, we kind of identify that second requirement on rotation, angle and center. Okay, 10 was a little tricky. First thing you got to do is, again, check orientation. A to T to H is clockwise, so is D to B to E. Now, some students thought that maybe the orientation was not the same because it looked like it spun. You're right, but that it spun, but the orientation is still clockwise. The arrangement of the letters is still clockwise, so orientation is preserved. So yet again, we're not going to need that line reflection. So step 1 won't happen. Line reflection won't happen. We don't need it. That only is used to fix orientation. Step 2, we're probably not going to translate because this is a rare case where it looks like we already have the center of rotation. If we use a 180 degree rotation centered at N, A will go right to D, which it's supposed to. And to me, it looks like H is going to go to E, which it's supposed to. So there's orientation and 2 points. I don't need anything else. It's not obvious that T is going to go to B. think I'm stuck there for a second. Oh, I've got to play. Sorry. And then H is going to E. That does work. So those two pairs of points mapping onto will be enough. All right, so it's just writing down orientation's preserved. It's going to be a rotation of 180 degrees, center to M. We'll map ATH onto DBE. Okay, that's it for page 3.